Namaskar my dear friends. So let us try to understand how we can select diodes for our circuit applications. So as you know, diodes are one of the integral part of any circuits that is there in the market right now. Any circuit you take up, whether it is a normal control cards where you have to have some microcontrollers and you are going to switch something, there also you need some diodes. You have a power supplies, so you will be needing some switching diodes. You have bridge rectifier, there also there is a diode which is going to work as like rectification purpose, so AC to DC. So almost any circuit you take, you will be requiring a diode. So have you ever considered like simply selecting a diode is enough, or do we need any extra like capabilities to select them? You cannot select a diode of, let us say, 200 volt rating and 1 ampere rating if you just need 20 volt signal with 20 milliampere current rating, right? So this is how the difference is. If you go ahead with this diode, this will also work, okay, at this particular application, but this will be overkill, like over design, isn't it? It will be having little bit higher cost as well, okay. So with increase in voltage rating and current rating, the diode cost increases. At the same time, the diode size will also increase. So you can see lot of different sizes are shown here, like it is DO45, DO35 package, DO41 package. Like there will be always one more thing. You can see there is a notch that is shown here, okay. So notch means it says that it is a cathode. So hope you know the diode is like this is my cathode and this is my anode, okay. Alright, before proceeding to this, what we will do is we'll try to understand one more thing as key. What are the different diodes? We have normal diode, right? Then we have a Schottky diode, we have ESD diodes, we have Zener diode, okay. Lot of symbols will be like this symbol will be like this. ESD diodes are also almost same, however they are used to suppress your high voltage transients, okay. And Zener diode and ESD diodes almost look same, okay. Zener diode will be little bit like this, okay. So we will be seeing all these kinds of different diodes in different sessions. However, our main target is to understand about diode and its normal switching application, like how it is allowing current from one direction to other direction. Let us say a very simple application of a diode is, once a power is given here VDD, okay, it will start allowing the current through this direction, okay. And as soon as it stops, this will stop, like there will not be any like allowance of current from this direction to this direction, okay. Like from this direction to this direction it will not allow any current. So that's the reason these diodes are basically used at the input itself, so that the system current should not enter into the input power supply. Input power supply should go towards the system. So hope you have understood the basic agenda of this particular session. We are not going to discuss about Schottky diode, ESD diode, Zener diode, and so many other diodes are also there. We are not going to talk about right now. We will be concentrating on diodes. Alright. So with this, let us try to understand what are the different parameters, what are the different specifications that we need to keep in mind before selecting a diode, okay. So let us say these parameters are basically, one of them is manufacturer, okay. So manufacturer will be must, like once you have the manufacturer, so manufacturer are whom? The companies who are producing your diodes. So some of them I am just listing it out for many young engineers who are like new to the industries, because many of you already know like who are the companies who are producing diodes. So mostly you have to concentrate on Visa, okay. Then onsemi, Vijay, onsemi, Nexpria. So they are particularly into those field, okay. And Diodes Incorporated. So these 4-5 companies are particularly into those fields, okay. And at the same time, we have Taiwan Semiconductor, we have Renesas, we have Infineon, we have Rome Semiconductor, we have Texas Instrument, one of the best company for diodes. We have Microchip, we have Burns, okay. We have ST Microelectronics, we have Little Fuse. Little Fuse has acquired IXYS, okay, IXYS. So IXYS was one of the best company for producing your diodes and MOSFETs and all. However, this has been acquired by Little Fuse, so Little Fuse is also having diode portfolio now. Alright, so with this, I am not limiting the companies to these only. There are many more companies in the world, okay, who are producing diode. However, these are some of them which we are, going ahead, we will be talking about, okay. Okay, so with manufacturers in mind, you can now proceed to select a diode. Why? Because these manufacturers are the ones which are going to affect you maybe 10 years from now. Let us say one part A you have selected from, let's say Nexperia, okay. What is going to happen is after 1 year, if you select from a local market or something, local companies or something, it will get obsolete or it will be removed from their shelf, okay. So that's the reason we always prefer some of the standard companies who are having some standards of manufacturing, and they have the promises of keeping the particular diode or particular component for longer amount of time, okay. Now coming back to the manufacturer part number. So manufacturer part number will depend based on your specification, like what is your voltage rating, what is your current rating, ampere rating, okay, and what is your reverse voltage, what is your leakage current, okay, like reverse current. This ampere will be IF and this is my V breakdown voltage or something like that. We'll talk about one by one each one of them. So basically we are not going to decide right now what is my manufacturer part number. At the same time, component description. So component description will tell us like which kind of diode it is and what is the voltage rating, what is the current rating, and what is the breakdown voltage, okay. Breakdown voltage is nothing but voltage rating that I am telling you. What will be my forward voltage, okay, what will be my package, okay, whether it is going to be 0603 or 0805, or there are a lot of other package like Diode 214 and Diode 219. So we'll talk about all the packages in detail little later, okay. So all this information will be available in the component description, okay. Now next parameter is, we have already understood about manufacturers, manufacturer part number, component description. Then we'll talk about technology. As I was talking to you, technology is nothing but whether it is simple simple diode which is going to be fast switching diode or a standard diode, or it can be Zener diode, ESD diode, or it is like a Schottky diode. Alright, so we have understood about technology, whether it is a diode or Zener diode or Schottky diode or ESD diode. We will understand each one of them separately, okay. Right now we are talking to about a standard diode, okay. Next parameter is repetitive peak reverse voltage. So as I was talking about what is the VR value. So basically let us say you have a power supply of 5 volt, okay. So you don't want to go ahead with 200 volt or 300 volt. You will go ahead with, let's say like a diode with 40 volt ratings, or maybe 75 volt rating, or 100 volt rating, or 200 volt rating, or 400 volt rating, or 600 volt rating, or 1000 volt rating, okay. So all the voltage ratings are available. So based on the requirement, you will be selecting a peak reverse voltage rating. Same way, this reverse voltage breakdown voltage almost is same. Peak repetitive reverse voltage is little bit higher side. All these voltage ratings that I told you is going to be your reverse voltage or breakdown voltage, okay. And peak reverse voltage is for very small time. What happens is, let us say you have a breakdown voltage rating of 75 volt, okay. Then this repetitive peak reverse voltage rating will be, for the same diode, it can be around 125 volt, okay. So this is the difference between peak repetitive peak reverse voltage and reverse voltage, okay. Same way we'll talk about rectified average current. What is the rectified average current? So let us say it is like a 150 milliampere or 200 milliampere. DC forward current. So DC forward current will be little bit higher side, okay, which can be, let's say, 200 milliampere. But I am talking to a diode about which is having these capacities. This DC forward current can be 1 ampere, 2 ampere, 5 ampere based on the requirement that you are going to choose. Okay. Similar to that, repetitive peak forward current will be little bit higher than your DC forward current, and peak surge current will be even much higher current, because surge current is what? Let us say you have a rating of 200 milliampere. This is going to be 300 milliampere. Okay, but at the same time with these ratings, my surge current can be as high as 500 milliampere. Okay, it means what? Like for normal utilization, you are using continuously this diode for 200 milliampere rate, okay, 200 milliampere ratings. However, if there is a chance that my current increases at the input to up to 500 milliampere, it won't fail. Okay, this is the reason they give different aspects of forward current rating. Okay. Some more parameters are forward voltage drop. Okay, so let us say what is the forward voltage drop. Generally you would have heard of 0.7 voltage drop is the forward voltage drop, but these days diodes are coming up to zero point 0.2 voltage drop, 0.3 volt drop, or 0.5 volt drop, or 0.9 volt drop, also 1 volt drop, also 1.2 volt, 1.7 volt. So all these voltage drop, like diodes are available. So based on your requirement, your need, whether you want that your drop is not going to affect your system, then you can go and choose little bit higher drop as well, as you try to keep lower side. So what is your requirement, that you have to choose based on your understanding and based on your requirement for the design. Okay, so this is the forward voltage drop. Like let us say you have a battery, and this is going to give you 6 volt. Okay, and you are going to use one diode and to the system. Now what will happen is, let us say if you are having 1.2 volt drop of this particular diode, then you will be left out with 4.8 volt voltage only. And suppose you need 5.5 volt or like something like that, then you don't want to choose a voltage drop of 1.2 volt. You will be choosing 0.3 volt or 0.5 volt maximum, so that 5.5 volt will be available at the output. This is why this forward voltage drop matters. Okay. Now what is my reverse recovery time? So reverse recovery time is nothing but how easily or how quickly it reverses to the normal position. As soon as you provide a negative voltage, it goes down and then it will try to settle down. So this time is your reverse recovery time. So for fast switching diodes, this time will be as low as nano seconds, like 10 nanosecond or 6 nanosecond or something like that. There are diodes which will take some 5 microsecond, so those will be very like slow diodes. Okay. Now reverse leakage current. So what will be the leakage current from this side when like system is ideal, like there is no power in this side, so the reverse leakage current is in microamperes range. Okay, so that also you have to take care in your parameters. What is the capacitance value, like between these two plates, what will be the capacitance? So this has to be as low as possible. Okay, otherwise unnecessary there will be a capacitance creation. Okay. Next, what is the power dissipation capacity? So power dissipation capacity across the diode is going to be what is your current and what is your voltage drop across this, right? VF. So IF into VF will decide what is your power dissipation across the diode. So as you can see that as you go ahead with a little bit higher amount of current, your power dissipation will increase. So based on your requirement, you have to understand whether it is 50 milliwatt capacity or 1 watt capacity, or like 10 watt capacity. So what is your circuit demanding? Based on that capacity you will be choosing a power dissipation of your diode. Okay. And power dissipation capacity also depends on the package size, whether it is bigger package size or smaller package size, that we will talk about in very detailed fashion now. Same way we have thermal resistance. So what happens is, in this particular diode, thermal resistance is nothing but theta j, that is thermal resistance across junction to ambient. Okay, so this will be in let us say 350 degree centigrade per watt. So for 1 watt of power dissipation across this diode, there will be an increase of 350 degree centigrade temperature. Okay, it means what? Right now the temperature is 25 degrees centigrade, and if you are using a thermal resistance of 350 degrees centigrade per watt, then for 1 watt of power dissipation, the total temperature will become of the diode is 375 degrees centigrade. Okay, so that you have to understand whether I am going to dissipate 1 watt power or less than that. If it is less than that, then accordingly the temperature will increase. Okay, let us say 0.1 watt is the drop. Then if this rating is there, then what will happen? 350 multiplied by 0.1, that is 35 degrees centigrade. So the total temperature increase will be what? 25 degrees centigrade, which is your ambient temperature, plus 35 degrees centigrade, which is the increment because of the power dissipation across the diode. So this is going to give you 60 degrees centigrade, which is well, like beyond, well in the limit of temperature range of your diode. Okay, now we will talk about mounting types. Okay, so mounting type is nothing but whether it is going to be SMD, that is surface mounting, or through hole mounting. Okay, so one of them can be SMD, one of them can be through hole. Okay, so through hole can be like leaded package or normal leaded package over uh, TO220 or something like that. Okay, so we'll talk about that also. So based on your space like availability or board requirement, you will be choosing a surface mounting or through hole diodes. The very important parameter that is there across the diode is operating temperature range. Okay, so what is the operating temperature range on which the diode will be working? Let us say it is telling you minus 55 degrees centigrade to 175 degrees centigrade. Okay, so the diode can able to work between these two temperature ranges easily. Now we'll talk about product status. Since you are choosing a product for your new design or for the design on which you are working, your product must be active. Otherwise, whatever the product, whatever the component that you have chosen will get obsolete maybe in 1 year or 2 years, so that you don't want to take a risk. Okay, so you must consult your manufacturer or have some third party tools like Silicon Expert is there, and even these days distributors like DZ Key, Mauser, they are also giving some information about the so product status you must take into account for your design. Once we are fine with our product status, we will proceed to RoHS compliant, right? So any of the components that you are choosing these days, it must be RoHS compliant. Otherwise, your product is not going to meet some of the standards that is required by IEC or like European standards and all. Okay. Then the very important thing that we were waiting for is package. So package I have taken at last so that I can give you a little bit broader idea about what are the different package of diodes that are available and how it is going to impact our design, right? Whether in case of a space sizing or in case of like the ratings of voltage breakdown and current ratings and everything. Okay. So I'm going to show you some of the diodes that is available in the market. Let us say it is the diode which is going to be DO220 package. So this is the leaded diode, axial diode. Same way we have DO4, we have DO41 package, then we have SOD64 package. So these are all power diodes, okay, which will be having little bit higher capacity. Even SMD package are coming up with power like capacity, little bit higher capacity, let's say 1000-volt breakdown or something like that. However, we have SOD323 package, okay, this is also almost same package. We have like DO213 AB package, we have SOD123 package, and one more thing I'll tell you, in SOD 123 package, okay, there are different kinds, whether it is SOT 123 or SOT 123F, 123W, 123D, lot of different extensions are there that is given by different technology of like of the pads. Okay, then we have just now I told you like SOD 123 F is like this and W is like this. Okay, then we have SMA, SMB, SMC, all these packages are there. One more thing you will definitely see that there is a packaging name like DO41 and DO2 node 4AL, right? Okay, so these are the packages that are like available. Even many more packages are there. Like we have a Diode 219 package, one of the best package that is there available in the market, which is very common package. Okay, and SOD 123 bit, like lower rating size package. Okay. So if you talk about another range, so we have SMP package like DO220AA, then SMA package, SMF package. Okay, so you can see the DO219 just now I told you, and then we have double like anodes also, like we have two anodes, pin number 1 and 2 both, and then cathode is single one. Okay, so this is going to be SMPC package. Okay, so there are several occasions where you need to utilize two anodes. Okay, if you go a little bit higher like ratings, then you go ahead with DO15 package, and we have micro SMP package, we have SMB package. So as I told you, SMA, SMB, SMC, SMP, SMF, all these are different package. Okay, now very best thing is we have TO220 package as well. Okay, so for very high ratings like 2000 volts or 3000 volts and all, even 1000 volts, we have DD2 package. So these are generally used in power supplies. Okay. Some other, if you take like GF1 package, that is DO214 package, DO219 we already talked about. SOD 128 has come from like an Nexperia. So you don't understand that these packages are only with one of the companies. Okay, the same diodes will be produced by almost many companies like Visa, Diode Incorporated, Texas Instruments, Microchip, Renesas, Nexperia, onsemi, many companies. Okay, so hope you have a good understanding about the diodes packages and its different parameters that is taken care. Okay, so this is the list that you can have handy for your reference, like 0402, 0603, 0805, 1206. These are general package for resistor, capacitor also. So at the same time diodes are also available. Okay, so packages, diodes we will talk about, and same way for SMA, SMB, SMC, SOD, all these different packages are there. We have TO220, TO247, TO263, and the list is not ending. List can be even higher. Okay, there are a lot of lists that I'm not listing out right now here. Okay, so all right, with this what we'll do is we'll try to understand this diode selection based on a like an example with a data sheet. So in our next session we'll try to explain one of the data sheet as well as one comparison table for different parameters of diode. Okay, so how we will do that we'll try to understand in our next session. And if you do have any questions regarding the packaging of diode, or like ratings of diode or different parameters of diode that you want to take into account for your different selections, or regarding the companies that you are taking into account, which are the companies that has to be preferred for your diode selections for long longevity of your diode selection, please put down your questions in the comment box and we shall be able to answer you out. Thank you.